Hi all, let's see the concept of semaphore. So semaphore is a particular bit or mechanism which will reduce the or resolve the problem of deadlock which are found in producer and consumer problem. So generally producer and consumer problem have deadlock problem, okay, and semaphore is continuously monitoring the producer and consumer sleep and wake up call of producer and consumer. Okay, so semaphore is a solution. You can think of it as a solution, and semaphore can be categorized in two types. One is counting semaphore and the other one is binary semaphore. Okay, binary semaphore is also called as mutex. So first let's discuss what is counting semaphore, and then after we will see binary semaphore as well. So in counting semaphore, more than one process are allowed to enter into the critical section. What I mean to say here, generally semaphore value is set, and based on this value we will allow the certain number of process to enter into the critical section. So if semaphore value is, let's say, positive, it indicates number of process to enter into critical section. Number of process enter into critical section. Let's say if semaphore value is +3. If it is +3, that means there are total 3 processes which are allowable to enter into the critical section. So if it is +3, which means we allow only 3 processes to enter into the critical section at the same time. Okay, and if S is, let's say, 0, if S is 0, then it means no process is allowed to enter into critical section. So if more than one process is allowed to enter into critical section, then definitely the primary requirement, mutual exclusion, is not possible in counting semaphore. And what about the other requirements? The other requirements are progress, bounded weighting, and architectural neutrality. So let's see them. These remaining requirements are fulfilled by this counting semaphore or not. And if S is equal to, let's say, negative, it means number of process present in waiting queue to get a chance to enter into critical section. For example, if S is equal to, let's say, -3, it means there are total 3 processes which are waited in a queue to get a chance to enter into critical section. Okay, and this particular 3 processes which are waited in a queue will get a chance in first in or first out order. Means based on their waiting time, they will get the chance to enter into critical section. Got it? So in counting semaphore, we allow more than one process to enter into critical section. This is very important point. More than one process is allowed in critical section. Okay, got it? So the progress, if we talk about the progress, here progress is guaranteed, because whenever the value of S is either positive or negative, or let's say 0, it does not affect other process to enter into the critical section. Okay, let's say I have S value 2, that means 2 processes, P1, process P2, simultaneously enter into the critical section. And if other process after these 2 processes came into existence, then this process would wait in the queue. So here progress is guaranteed. Okay, so progress is guaranteed. And what about bounded weighting? Bounded weighting is also here guaranteed. Why? Because the process which are going to enter into the critical section is bounded by this semaphore value. Okay, the process, all the processes which are trying to enter into critical section is bounded on the semaphore value. If semaphore value is positive, then the process will be allowed to enter into the critical section. If it is negative, then they will wait in the queue to get a chance to enter into critical section, and if it is 0, then no other process will allow to enter into critical section. So definitely bounded waiting is also guaranteed, and operating system should provide functionality so that this counting semaphore implementation is possible. That means here architectural neutrality is not provided. Architectural neutrality is not provided. Why? Because operating system should take care of this counting semaphore variables. Okay, so it is platform dependent. So we are talking about the requirement. One is mutual exclusion, progress, then bounded waiting, and last is architectural neutrality. So mutual exclusion is not provided. Why? Because more than one process is allowed to enter into critical section. Progress is allowed, bounded waiting is allowed, and architectural neutrality is not provided. Why? Because operating system have the responsibility to take care of counting semaphore. Okay, so it is basically platform dependent. Okay, so that's all about counting semaphore. In the next video we will see binary semaphore.